All right, well, I think we're going to get going here. First off, this is a recorded session, so if you have questions, I love questions. So if you have any, please let me know, and we'll either get you a microphone or I'll try to repeat them for you as best as possible. So thank you for coming. This is day 3. Everyone's brains are pretty full by now. You're agreeing. I hope you have a few more spaces, a few more cycles for what I'm going to talk about here right now. My name is Tim Johnson. I'm a product marketing manager for CloudBees on the Accelerator product. And with me is Mohan Dattatreya. You're the director of engineering for Accelerator. Mohan's been with the company about 6 or 7 years. Accelerator as a product has been out for about 15 years now. And there's quite a few things that we've learned. We want to talk you through a little bit about how to buy more time. Everyone is trying to go faster and faster and faster these days, and there are things that can, typically get in your way. And we're going to talk a little bit about that. So has anybody not seen this quote? Every business is a software business, right? I think people have been saying this or repeating it for about almost 10 years now. But the part that I found interesting was the part of the quote that was never really included, because Marc Andreessen went on to say that compressing cycle time is probably going to be the biggest place you're going to make the most wins. Now we've seen with CloudBees Flow and with CloudBees Core and pipelines and stuff, we've seen that whole idea to dollar sign compress significantly, but a lot of it tends to be on the right-hand side with environment management, pipeline management, release orchestration, things like that, manual processes and gates and all that other stuff. We've automated that. You can get that down, but the stuff over here on the left, that build and test cycle still tends to be pretty long. And if you can get that down, you can increase things, not only burn down rates on features, but you can get to learning a lot faster. So if you think about it, how many people actually write code, or engineers, developers, right? So what's one of the things that, I'm going to lead the question here, the most important thing for you is getting to learning. Did that piece of code I write work? Is that correct? And then subsequently, did that piece of code I write deliver any value? Right? So if you can shorten that time, you're going to be a lot better at what you're doing, probably be a lot happier. Who's read the Phoenix Project? Right? Good reading, easy read. Gene Kim is writing a follow-on book called The Unicorn Project, and he's introducing 5 ideals. And one of them is flow and joy in your daily work. And that's important, because I want to think about this. So if you think about your daily build and test cycle, can take a long time. And is anybody really good at ping pong? Right? There's one back. At least you admit it. Thank you. I was at a company a number of years ago that, I won't tell you how many years ago, but the builds that they were doing were 3 to 6 hours long every day. So they were doing ping pong a lot. And every day, or every so often, we'd have a company ping pong tournament. I was in sales. I had quota to make, so I was busy, but competitive guy that I am, I'd always jump in, and I always got whooped by the developers because they were spending a lot of time on that. Now, maybe you don't spend a lot of time on the ping pong table, but when you're waiting for builds and tests to complete, what do you do with that time? Debug the garbage collection. Debug garbage collection. You try to find other things to do. And sometimes those might be valuable things, but a lot of times, if you're really in the zone, and then you got to wait, it takes you and these are studies that show this, it takes you anywhere from 30 minutes to 2 hours to get back to that same creative state that you were in. So anything that we can do to shorten that is going to make you happier and going to make the whole process a lot faster. And I want to look at some of the effects of these long build times. And I'm not making these numbers up. These numbers come from a lot of our customers that we talk to, primarily in the embedded systems space, the transaction processing space, where you're building and testing things like you're building an Android OSP, you're building your C code, and then you're the middleware and all the other stuff. And these build cycles can be really, really long. Cisco was a customer of ours, and they had a build that took 20-some hours to complete every day. Who'd like to be playing ping pong for that long, right? So there's some really detrimental effects when you've got long build times. And the point of it at the end of the day is there's nothing continuous about your continuous integration or continuous delivery if your builds and tests take a really long time. One of the other things that happens that we've seen at a number of places is that developers get cautious. You're focusing more on being right. I hope this doesn't break, rather than being creative. And you slow down. And everybody, the whole team slows down, and they try to, because as the longer, the bigger the penalty for the build, whether it's incremental or full build, the slower things go. So it kind of feeds itself and it slows everything further down. So get it faster. What can you do to make that process go faster? So if you're down under 30 minutes for full builds and incremental builds, then you can actually claim you're doing continuous integration. I can have a dictionary that supports that, what continuous means on that. Does everybody kind of agree with all that? What kind of build times are you dealing with? How about you, sir? 2 or 3 hours. And you? About an hour or so? Okay. Enough time for lunch? Sometimes. How about you? 10 minutes. Okay, you're doing Java builds? Okay, all right. So one of the things that's happening, what's causing this, what's making this expand is, especially in the IoT space, is the code base is just increasing. If you look at Android, how big it gets. It's keep going up. The Android, was it Q is the next version? 60, 70 million lines of code, and the build times for that are kind of matching that. There's some uppy downy with that. So those build times are going. So you look at the amount of intelligence that's in a car, that's in your refrigerator or dishwasher, the phones in your pockets. You look at the intelligence that's in there. It's just amazing that a car has more code than an airplane does. 15, 20-year-old airplane. And that's going to continue. The other thing that contributes to build times is builds are really complex. I'm sure you guys are good engineers at it, but the builds can be really big, really long, especially with Android. Here's an error that's in that code. Now with Android, if you happen to load up the log files, it's typically 15 megabytes or more of just lines and lines and lines of stuff. And then who likes slogging through that to find what the error was? Right? I don't see any hands going up. The Ninja log file, 40 megabytes, 3,300 make files. There's a lot of stuff that's there. There's a lot of moving parts, a lot of things that can go wrong on that. So what we've seen from a lot of our customers on how they try to address this and fix this, and be honest, raise your hand. Who tries to increase your build times by parallelizing it manually? Right, you're using make, and you do, was it /J? Right? People do that? Anyone does that? Right, there's a couple. But really, that you're not being paid to do that. You're paid to be innovative, not figuring out why the build broke. Right? That's not a good use of your time. Or at least we don't think so. You probably don't either. My builds will go faster if I have bigger hardware. Anybody ever said that? All right, good, honest. We found that that actually isn't the case. The more hardware you buy, the slower the build goes, and the lower the utilization. Now, nobody's got unlimited budgets to keep buying more and more hardware, but we were talking to one of our customers. If you've ever used a card reader, I'm not going to tell their name, I'm not allowed to. If you ever used one of those little card readers that sticks in your phone, or go to a restaurant and there's a little square logo on the device, that's our customer. They were saying that their developers insisted adamantly that if they just had bigger hardware, they'd go faster. They didn't need anything else. So they blew the money, got them the bigger hardware, build slowed down. Because it made it more complex for them to manage that environment. The more cores they had, there was more grunt work stuff that they had to do. The actual time doing the build may have increased a little bit, but the time it took to get the build to complete, front to back, actually lengthened, right? Who does this? We talked about this earlier. If the build and test cycle is so long, let's do fewer builds and do fewer tests. What that actually does is that shifts your QA all the way to the right to your customers. Right? And if you're building engine management systems, braking management systems, aircraft management systems, heart monitor systems, blood pressure management systems, you know what a product failure there is called? An autopsy, right? You can't do that. You can't cut down on tests or things, but we know of customers who have done this to try to go faster, and that's not really acceptable. The other thing is just accept that that's the way it is. That's my pain. This is my cross I have to bear every day is these 1 hour, 2 hour, 3 hour, 4 hour build and test cycles. And there are other companies that think that's a better way to do that. So what they've done, we take a look at maybe there's a better way of doing that. And how about if there was a way to take those builds and intelligently and automatically distribute them optimally across the available resources, however many cores or however many cloud resources you had. If it just did it for you automatically. So you didn't have to mess around trying to debug a broken build. Builds work, the builds were guaranteed. How about if you had a way to not rebuild stuff that didn't change? Why waste the cycles on rebuilding components that I didn't make any changes to? Right? So that way you're not spending cycles, burning cycles, doing nothing. Or how about if you had the ability to dynamically grab whatever resources you needed for that build, and you could actually pick how long the build was going to take. You're in a real hurry. I need this build to complete in 2 minutes. 5 minutes isn't good enough. I need this sucker done now. If you had that ability to do that, then that would open up a whole lot of possibilities. So you said your build is about an hour or so?
Some builds are 1 week. You do a lot.
1 week?
Yes.
Wow. That's not a productive week. So if you got it down to say just a simple 5x improvement, so that would be a day, what more could you do in that week instead of waiting for that, right? That would probably fundamentally change your life, wouldn't it? And then just the analytics, being able to go in and see where are things that do I have enough capacity? Or are there things that I can do to the build that can make it even more efficient without having to slog through millions of lines of log files? So that's kind of the setup. Now I'm going to hand it over to Mohan to talk a little bit about how CloudBees Accelerator, I came from Electric Cloud, by the way, a little bit about how it works.
You've heard from Tim about the problem. So how many of you think your CI cycles are too long? So, and let's put it another way, right? The question is, if you could go faster, would it help improve your developer productivity or not? So that's the problem that CloudBees Accelerator is solving. And you've heard all of this, and you're wondering, this sounds too good to be true. Can you tell me how it works and how it can make things go several times faster? So that's what I'm going to talk to you for the next few minutes about. And if you have any questions, like Tim said, I'd love to answer any questions you have about this. So the first way Accelerator helps you go faster is by utilizing more cores. You could use your build tools, multi-threading, to utilize the cores on your local machine, but Accelerator can help you use cores across several machines, right? So you can set up a cluster, and you can do the same job that would typically take you, if you were running on a single machine and a single core, let's say it takes you 40 minutes, you could shrink that down to 2 minutes as long as there was 20-way parallelism in the build. And that's the first way through distribution of cores that Accelerator will help you go faster. The second way it helps you go faster is you run a build and you deposit the executables or the artifacts from the build in a central shared cache. And then the next time you run the build and you see that none of your whatever you're building, the environment hasn't changed, the compiler options you're using hasn't changed, so there is no need to rebuild, and you can replay from the cache. So as a result, you can see that only one of the components had to be rebuilt, and the rest of the components were replayed from cache. So those are the two ways Accelerator helps you to go faster. Any questions on that? So the next part about this is, so you might say, hey, this sounds simple enough, so what makes Accelerator unique? So Accelerator is a product that became part of CloudBees through CloudBees acquisition of Electric Cloud. This product was created by the founders of Electric Cloud, one of whom was a professor at Stanford and the inventor of the Tickle language, if any of you remember the Tickle scripting language. So there's a lot of IP in it about not only can you make the build go faster, but how do you guarantee that the build is correct? And what do I mean by that? So you run things in parallel. They can run out of order because your dependencies aren't fully specified. And you could run things in the wrong order, and the final executable that you get is not correct. And so what good is it if you can run faster across many cores, but you aren't guaranteed that the output is reliable? So that's the problem that Accelerator solves. There's a lot of IP behind it, and Accelerator has been granted 8 patents just on these, many of the aspects of these technologies. So the key point here is that you can be comfortable using Accelerator not just for your developer builds, but also for your CI and production builds. And we have several large customers like Tim mentioned, Cisco, GE, and GM. You can go check out the companies who are using Accelerator. The product has been shipping for over 15 years. And so that's how it helps you to guarantee reliability as well. Any questions on that? So the last part of it is, so the final question we often get is, do I really need to use Accelerator? Why don't I just buy a more powerful machine? And the answer is that we not only help our customers go faster, but we also help them save on the number of cores they need, or save on infrastructure. And there are several aspects to this. The first aspect is that it intelligently, so let's assume you have a setup where you have different configurations of servers. Some of your servers are 8 core, some of them are 16 core, some of them are 32 core. And so what Accelerator does is it converts all of the cores across all your servers into a virtual supercomputer, if you will, and makes that available to any build that is launched, whether it's from an automated CI system or from your developers. And so it helps to make more efficient use of the cores because let's say you were using gmake minus j and you specified the level of parallelism to be 32. That means for the entire duration of the build, 32 cores are locked up, whether or not you need them. In comparison, Accelerator will figure out at different points of the build, you might have needs for different number of cores, if you will, and you can automatically allocate the right number of cores at different stages of the build, and so all of those cores are not tied up. The second way we already talked about that is caching. So if by eliminating work that is not necessary and that is redundant, you are saving a lot of workload that would otherwise have to be done. And then the third way is, so let's say you're going to the cloud, you are only provisioning these instances when you run the build, and once the build is done, it can dispose of them. So you can dynamically spin up these EC2 instances or GCP instances on the fly, and that's a feature called cloud bursting that enables you to make more effective utilization of your cloud resources. So those are the three ways that Accelerator helps you to go faster. Any questions on this?
So first question I have is, what if your Jenkins master and runs in Kubernetes, and you have workers that run your builds? Can Accelerator work with that?
Yes, yes. So the way this would work is, so in your Jenkins master, you're running a job, and that job represents your entire build, and that job is where Accelerator comes into the picture. So the job is being executed on a Jenkins agent, if you will, right, on a node. But so there is a further set of agents that Accelerator will then leverage when you run your build, and that is not your Jenkins agent. So you're running the client piece. So let's just take an example. You're running, let's say you're using make. You replace make with emake when you use Accelerator. That's our drop-in replacement. So you run emake on your Jenkins slave, and emake in turn is going to spin up a bunch of agents, like you said, in Kubernetes, which will, for the duration of the build, bring up those instances, parallelize it, and then once the build is done, it shuts it down. So there's a second tier of agents that are instantiated if you're using cloud bursting, or you can statically set them up if you're on premise and you have hardware. And so that's kind of the hierarchy, if you will.
I have one more question about dependency scanning.
Uh-huh.
So does it recognize like most common languages, or is it like, are you talking about dependencies in code? Like my yarn dependencies or shared libraries and stuff like that, or are you talking about other dependencies?
Dependencies in, say, in your build system specifications, so like in make files or Ninja files or in Visual Studio projects. Yeah, yeah.
Is the caching technology available to developers on the local environment also?
Yes. So there's a two-tier cache. So you can either go to a shared NFS location and you can fetch stuff from there, or you can use your local cache. No. So that, like I said, there are certain build systems that we support out of the box. The most common ones that our customers use is Make and Ninja, which is a build tool that came out of Google and is used by the Android project, and Visual Studio. Maven is not supported at this point. No, Gradle is not supported at this point. So, but let me ask you a question. So, are your builds long enough that you're looking for a solution to speed it up? Because my understanding is Java builds are typically very fast. Is that? Build itself is fast. So the deployment to Kubernetes, or if you're pulling some packages from the internet, that's not something Accelerator can help you speed up, because that's still, you're going to have to get those, or you have to fetch your Maven dependencies. Those are things that even if we had an out-of-the-box solution, we would not be able to, as long, you would have to cache all the things that Maven needs upfront and use them.
So it looks like where Accelerator really shines is like large build times, large monolithic build times.
Correct.
But if you have something that's a little bit sleek, I have a 10-minute build. That's all because of the dependencies pulling from shared libraries in Yarn, Node. So that really, Accelerator can't really help there.
That's right. Any other questions? Thank you. Yeah? I'm sorry, can you repeat the question, and can you give me a little bit more? So the cluster manager is only for setting up your cluster, and the cache resides on the client side. So when you launch a build, like I was explaining, if you are using make, then you replace it with emake. So on your the emake is the one which is accessing the cache. That can be either on your local hard disk or on an NFS location. So with that, sorry, what was the question? Yeah, it is all automated. So the caching process is the following. You run a build once, and the output of that build is stored in a shared location. And then every time you run a build, you point to that shared location, and it'll automatically check if this module was built before. It also remembers what the environment was, what the command line parameters was. It also stores the checksums for all the source files. And if it figures out that nothing has changed, then it will reuse it from cache. Any other questions? So the last, okay, so I already talked about cloud bursting. So here the key point is the cluster manager, which she just mentioned, allows Accelerator not just to speed up one build, but several builds that are running concurrently on the cluster. So you have a team of hundreds of developers. That's where Accelerator can help to load balance all of the builds and the request for cores that are coming in and manage that. And you can even have priority builds that can bump off other builds that are running in transit without causing them to fail, and take over those cores and run them for, let's say you have a priority release build, then you can set those up on the cluster manager. So let me quickly walk you through what the process is of if you felt that Accelerator was something that might benefit you. Here's an example of how you would integrate it. So let's assume you're using GNU Make, and you have a build that's running on a single machine using a single core. It takes an hour and 10 minutes. And then you go ahead and then you run it with Accelerator. And what you see on the right-hand side is a visualization of the build that was run across 10 different cores. Each of those rows represent a different agent/core, and all of those tiny rectangular boxes represent the work that's happening on that agent. So you can see it's fairly well parallelized, 10-way parallelized. And the first time you run the build, you can see there's about a 20-minute reduction in time, and you're saying, is that all Accelerator can do? But essentially, this is what we call the learning build. I mentioned that Accelerator can automatically learn the missing dependencies, and it can populate the cache, if you will, during that initial build. So that's why you see a 20-minute speed up. And then you run the build, and you can see from here that the first time it ran the build, and this is the technology I was talking about that there are patents around, is it detected that 778 things ran out of order. That's what we call conflicts, because you try to run them in any arbitrary order. So let's assume, and this is because the make files may not have those dependencies perfectly specified. Nobody writes perfect build specifications. And when you run them in parallel, a lot of these missing dependencies gets exposed. So those jobs that were run out of order, because we have an underlying distributed file system, we were able to detect that and rerun those jobs. So that's why it took a little longer. So you run the same build again using the history, if you will, from the first build and leveraging the cache, and you can see that the build is completed in 5 minutes. So this is very typical of the kind of speed up you would see if you were using Accelerator. You get a 5 to 10x speed up. So the question now is, can you go any faster? So then you can go into Insight, which is a analytics tool that will suck up the 40 megabyte log file you have and give you metadata about the build, how long all of these jobs were taking, what the critical path in your build is. And then you can go in and use the simulator report in there. And that simulator report will help you to figure out if you added more cores, is it going to go any faster or not? So that's how you can make a determination for what the right set of cores to use for your build, and depending on what your build time targets are. Any questions on this? Yeah.
All right, so let me turn this on. All right, so we're going to take a few minutes talking about some of things that our customers have been successful with, and because the proof is always in the pudding. And we don't, we're not making this stuff up. Zebra, has anybody heard of Zebra? They make ruggedized industrial Android devices for healthcare, warehousing and logistics, transportation, and other devices. And they came to us with a classic problem. Their builds were too long, but also their builds were unpredictable. It was anywhere from 2 to 5 hours. You see up here in this chart, 2 to 5 hour times. They just didn't know. They might have conflicts on the servers or the cores or whatever. It was just, let's kick off a build. Are you sure? And sometime later it would come back. And they had limited budget, so they had considered, let's go buy some more infrastructure, and then well, we really don't have any money for that. But they came to us and they ran Accelerator, and you see their builds went from 2 to 5 hours down to 10 to 23 minutes. It kind of depends on what was changed, what was in the cache and what wasn't, and so forth. But instead of 2 hours, it was down to less than a half an hour, and it was predictable all the time. And so they saw that speed up on their existing infrastructure. So they got 4x throughput on the number of builds they could do during a day on the same infrastructure. So that's one. I mentioned Square earlier. I was kind of facetious about it, but they said if we just had more hardware, it would go faster, and it didn't. And again, they had the same problems of variable builds of 47 to 90 minutes. Now they all run around 11 minutes long. And that's the difference of 2 iterations a day to 4 or 5 iterations a day. So getting that feedback all that much faster for them. And they tried Ccache and they tried some other stuff, trying to do it on their own. And they also saw a significant reduction in their infrastructure load. So they're running getting this performance on about half or just under half their existing infrastructure. So anybody manage infrastructure here? Okay, they have one of those. So you get better utilization on that. And the last one is Cisco, and these are also very interesting as well. Their build was something around the order of 20 to 24 hours long, and which is bad enough, but the awful thing was, it'd be chugging along, and somewhere around hour 18, the build would fail. Right? Ouch. Right? And then so somebody would have to go debug the build, and then you'd have to restart the whole thing from scratch, rather than where it failed. And they were also, their developers were complaining, if I just had this 32-core, 80 gig of RAM workstation, I could do this all myself. Well, that's about $25,000. And when they have 8,000 developers, yeah, you're laughing, right? Who's going to actually take that budget request up the ladder, right? Not happening. So they'd set up an entire data center dedicated to just doing builds for them, and found that it was, the bigger it went, the bigger it got, the less utilization happened. The more they had, the less they got it used. So instead of having like 80% utilization, the bigger it got down to like 40% utilization. So they brought us in, and they have 8,000 developers now, saving 400,000 hours a year or more, spending time on innovation rather than just waiting, twiddling their thumbs or whatever. But they also found they could actually kill an entire data center. It's 3.2 gigawatts of power alone that they cut out of their operating budget. And that was somewhere around $3 million just by doing that. So that more than paid for the software just in and of itself. And now the developers are really happy because things go really fast as well. All right? So I'm going to wind up with a couple of obligatory marketing slides here. So instead of the slow builds and tests, now you can go really fast. And instead of spending lots and lots of money on infrastructure, now you can use it a lot more effectively, and cost effectively, and you've got that visibility and insight to make things go faster. And that's what I wanted to say about it. That's what we wanted to present about Accelerator. So thank you very much for spending your time on day 3 and asking some good questions. If you have additional questions, we're here for a few minutes, or you can come over to the booth and we can go in a little bit more deep dive into that. So they're serving lunch right about now. So thank you very much.